I'm Joel Halpern, a distinguished engineer with Ericsson. This is Brady Johnson, also with Ericsson, one of our key guys on service chaining. I co-wrote the architecture document from the IETF on service chaining. Brady is the project lead and ODL on it. So we've had to work together. And what we want to talk about today is the relationship between and the positive feedback between standards and open source. So we're going to go briefly, just so you can see the timing involved, through a timeline of the work in the SFC, in IETF and ODL. And then we're going to talk about what happened. How did the work actually take place in each of the places? And as we do so, we'll talk about the feedback that occurs and the relationships. Because you'll hear people say standards are dead, and there are some standards folks who are foolish and say, oh, we don't need open source. Let's be clear. This isn't actually new. Back in the early 90s, I was building routers, and we used the GateD consortium routing stack, which was open source, which everybody contributed to. But we were a commercial company, and we were all working in the IETF on the standards. So the key is the relationship between them, because open source implementations can provide really, really good feedback to and leverage of standards, and are important for commercial, as are the standards themselves. So just to put the timeline in perspective, this particular activity, service chaining as a standard and an open source activity, goes back roughly to June of 2013. Now that doesn't mean people weren't doing it before then. They were. We know that. So I'm not saying we invented it then. We didn't. We picked it up and started moving. And so we got officially chartered in November. The Yang model draft, which, since you guys are familiar with ODL, you can imagine the Yang models are fairly important parts of that. They started work on in December of 2013. Now we've had the RFCs on the architecture accepted. We probably, within a couple of more months, will have the RFC on the encapsulation, NSH, accepted. Meanwhile, ODL has been going on, and the SFC project goes all the way back to helium. It wasn't a hydrogen project, but it was a helium project. And it has been moving forward and improving and being driven to reflect the capabilities as we worked out the standards and been improving the standards by its activities since then. So the NSH was discussed and implemented in ODL before the IETF working group accepted it. So by the time the working group said, yes, we like NSH, we knew what it took to implement it, what the effect on implementation was of the choices in NSH. So there's a very positive relationship. So just for those of you who don't know IETF, the way we do our work in the IETF is typically by email. We're not, there are folks trying to use GitHub for various things, but the work is done by email. So the email list I had to go digging to figure out, was created in June of 2013, and the initial documents were submitted then. So the problem statement and the NSH draft started their life at that time. And one of the things people complain about with standards is that it takes so long. Well, sure, but when you have a lot of people looking at things from a lot of different angles, it takes time to have the discussion. But that time is not a waste. It's not lost. It's actually a benefit. There are a lot of features in NSH that were added because of those discussions that will enable us to address a much broader set of use cases, a much broader set of deployments. Some of those issues were found in doing the implementation in ODL. Some of them were found as people brought their own experiences to bear. So one of the things to keep in mind when you think about the time, you can rush to code. Sorry, I'm really old school in this game. I'm back in the carpenter's paradigm. Measure twice, cut once. I'd rather spend a little more time thinking about the problem I have to solve, thinking about the architecture of the solution before I commit to code that's going to lock me in. Now, sometimes in open source, we have the ability to say, well, we'll just do a new project. But when you go look at commercializing product, it's a lot more painful if you've made raw choices. So having a place to think and compare and analyze in parallel with a place to implement and them feeding to each other is a very positive experience. So the problems were defined at the IETF, and the data plane description was laid out, and then ODL has used that. Now, I'll give you an example of where sometimes things don't work so well. The ODL code uses a term, realized service path. Unfortunately, they use it differently than the standard uses it. So we're now going to have to sort out, did we need this other term? And I believe we do. And if so, how do we get things back in sync? But the reason it was used.
I'll make sure that gets fixed.
And the point is, there's reasons on both sides. It was, we need something for what's going on in the network, and if you haven't thought about all of the other deployments, you tend to create narrower terms. So we've had a very good place to agree on transport independence and resolve a lot of the issues. Just for context, we're now working on things like OAM, which really requires people talking about all the different problems, even while ODL is implementing, here's ping, here's traceroute. What does it really take for an operator to be able to use this in an operational environment and take it forward?
Thank you. Okay, so the Open Daylight SFC project was created with the intention of being an implementation of the IETF, NSH, and SFC drafts and standards. So how did that help us? I mean, what did we get out of that? Well, effectively, that established a baseline for us. We already had an IETF working group created. There's already a problem statement created. There was a detailed problem statement. So it was much easier to explain what we're trying to do here. When I wasn't involved then, but when the project was pitched to the TSC, it was quite simple. We just said, well, here's the problem statement, and this is it. And also NSH. I mean, NSH is the network service header protocol. It's a new protocol. We all know how difficult new protocols can be. But NSH had already been widely discussed and reviewed and debated, and it had already been accepted that there was a need for this protocol. And all this was in place when we started with the project. So it's very useful in getting the project started. And likewise, I was involved integrating Open Daylight SFC into OPNFV SFC. It was very useful already having the implementation of Open Daylight SFC there, but again, like when we started Open Daylight SFC and OPNFV SFC, we had this background, everything established, this baseline of the IETF standards and such available. So, as Joel mentioned before, the inputs and feedback and such, I think it's very useful, very powerful that the two communities, IETF and Open Daylight, we work together and we get feedback back and forth and such. For instance, the forwarding structure of NSH. I mean, we started on the drafts. Then we went into Open Daylight to take a look at how's that going to work. Was it better this way or that way or whatever? Likewise, with the metadata, the NSH metadata and service function forwarders. So I think that that sort of feedback in both directions really enhanced the specifications. So as Joe mentioned before, I mean, SFC is not the only project that has ever had this sort of collaboration between the standards and the implementation. I mean, we all know Yang. I mean, Yang is a perfect example. Yang is like the core technology in Open Daylight, which is supported by a standard as well. There's the I2RS. I don't know that so well, but Joel is very involved in that, which also used Open Daylight to prove the protocol could actually work. So here are some references here of the different documents available, how to get into the SFC project, both in Open Daylight and OPNFV. Are there any questions? Yes.
If you go back to the previous slide, so you mentioned I2RS. What's the status of that?
Okay, so the I2RS work, the underlying architecture has been published as an RFC. There have been some open source implementations of possible protocols, because the main activity underway right now is to finish up agreeing on exactly what is the protocol model for this. It's using Yang, it's using netconf and restconf, but there are certain additional behaviors that I2RS, in order to enable really dynamic behavior, requires that are not covered by the current definitions. And the documents describing the requirements, as well as the security requirements, are in final discussion with the working group and the IESG, so that those can be worked then with the relevant netmod working groups to get the enhancements. And people have been attempting to implement open source versions of this to see what happens when we try to do this using real code, not just, well, we can write a Yang model, anybody can do that part.
Specifically, what problem I2RS can solve for ODL? Is there any problem that
Okay, ODL, so I2RS defines a client and an agent. ODL is very well suited to be an I2RS client, because ODL already supports very high transaction rates, has its own model of the world, and understands changes it wants to make. It already is set up to be able to use Yang to make changes. If you have things that are more dynamic than you want persisted, and you have things that you want faster changes, so you want lower validation rates, and a lot of other drivers for I2RS, ODL can serve as a very effective client for driving exactly those operations into an I2RS agent in a router. So what the purpose of I2RS fundamentally was to enable routers to be controlled by policy the way forwarders are by OpenFlow or OVSDB. And from an ODL perspective, you want to be able to control the network, whether you're using routers or forwarders or any of the other devices people use. So I2RS is a element of the southbound from ODL that fits very well in the work we do here. Other questions? One more back there, yes.
More about the implementation itself.
Can't hear you.
Did you start to move to the new network with the VPN service?
Did we, the question was, did we start to move to the new network?
Yeah.
A bit off topic. We will move to the new network in the Carbon release. We just finished the Open Daylight Boron release. We're using effectively what's called the old network, and then we'll switch to the new network, which will integrate with Genius in Carbon.
Okay. And I have a second question. What is your experience with actually the VNF that you implement in NSH? So that's kind of the challenge over here.
Yeah, that is the.
Repeat the question. Other folks want to find out.
The question was, what is our experience with the challenges of with NSH in VNFs, and that is the challenge. And it's a new protocol. I mean, this is leading edge. I'm not going to call it bleeding edge. It's leading edge work, and there's a lot of work involved. There's a lot of companies behind this. Obviously, Joel's not the only author in IETF. There are folks, I mean, in IETF SFC and NSH, there are folks from Intel,
Cisco. Lots of other
Huawei,
companies.
yeah. Point is, there's a lot of people, a lot of companies behind it who're bringing it forward. It's not going to be completely available tomorrow, but we're on our way.
So let me elaborate on that. NSH, the NSH documents, and in fact the SFC architecture calls out the fact that moving to a new network, a new encapsulation for supporting service chaining requires transition. So you're going to need proxies. And in fact, we see folks in the FIDO open source project, because that's data plane, looking at doing an SFC proxy for certain common classes of applications of virtual network functions that need to be connected.
It's already available or it's been implemented.
Meanwhile, we see folks who implement VNFs going, okay, since NSH is going to be the de facto interoperable way to carry service chain identification and metadata, we as a VNF implementer will implement support for that in our function. So yes, it will take time before it's widespread. We have folks solving the problem both from the point of view of improving their VNFs because they get additional capability by having the interoperability and the metadata support. And we see people implementing both specialized and generalized proxies to enable work with legacy, both legacy VNFs, I know that's a sort of odd phrase, but also legacy bare metal applications so that we can include bare metal in service chaining. And that's come out of both efforts to build prototypes here and efforts in the IETF to discuss what does it take to make this work for operators.
So you're as an Ericsson, right? You have a bunch of VNF by wont, and any visibility for the next few years of having a VNF.
We're going to do both of we're going to take both of the techniques I just described. I mean, we know that. And it takes time, and timing I can't commit to when we will have what piece of solution. That they'd lynch me if I try that.
Okay, that's a very good point. If you're going to take the fixed header and the variable header, that the RFC is going to really spell out.
One last thing, sorry to interrupt. Just if you would like to see the implementation of this, we do have a demo running in the demo booth, the Ericsson booth. So you can see this OPNFV SFC implementation. No, there's several people leaving. I just wanted to mention that first. Yeah.
Yeah, the introp in the context of IETF, is that allowed the fixed and the variable header to interoperate?
Okay. You can't, any given transmission of a packet with an NSH header will have to use either mode 1 or mode 2. You could translate, but I don't expect anybody to do that. The expectation is, and the expectation is that most deployments will be heavily either mode 1 or mode 2, although you can, and people have done some work on how, have deployments which use both, but any given chain is going to be using only one of them, because otherwise life gets to be just an operability nightmare. Forget interoperability, just operability.
No, just type 1.
Right now. There are commitments to support, and the work on, so even the work in FIDO, we're doing type 1 first, but we're also, the project says, and we're going to do type 2. Of course, that means we got to have people who are working on it. Thank you all.
Thank you.